New video. Question 1. Write an equation in slope intercept form. Alright, so there's going to be a couple things we're going to use here. 3 equations that we should work with. 2 of the equations are going to solve the third, so you don't really need the third one. But slope intercept form, the equation is actually here, slope intercept form is actually y is equal to mx plus b. That is your slope. That is your y-intercept. Now, if you can graph your equation, or they're going to give you points, if you can graph the points and you can see the y-intercept, you can just use that. Otherwise, we'll just use the equation to solve it. All right. Now, so we're going to use slope. All right, and that's just going to be y2 minus y1 over x2 minus x1. All right, slope. This formula will get us m. All right, and then we can also use point slope form. All right, this is the equation we're going to use basically to solve the rest of this. All right, we don't really have to do a lot of math, but just a couple little things. And that one is going to be y minus y1 equals m x minus x1. And that's about it. That's what we're going to be doing today. All right. So let me give you some examples. We got to write that so the camera focuses. All right, so let me just give you some sample points, plot points. All right, so let's do minus 3, comma 3. That's our first set, and let's do 3 minus 1. All right. Now, if I graphed it just so we can see, we don't really have to, but it might be helpful. Negative 3, 1, 2, 3, positive 3 up on the y, 1, 2, 3. So there's the first point, minus 3, comma 3. And then we have 3 on the x, 1, 2, 3, and negative 1 on the y. So 3, comma negative 1. All right, and here's our line. Now I can't really say what the y-intercept is here, so that's why we're going to use the other equations. All right, so the first thing I'm going to do is the slope. All right, so let's write that down just so we have it. 1, slope. Remember, slope is just y squared minus y1 over x2 minus x1. All right, now I usually label mine just so I don't mess them up. So that's x1, that's y1, that's x2, that's y2. And it doesn't really matter, like if I put this one first and made this x2 and this y, or x1 and y1, it doesn't matter as long as you're putting them in the right order. So let's go ahead and try and solve this. y2 is negative 1, y1 is 3. All right, and x2 is 3, x1 is negative 3, so it's a minus 3. Remember to do that. All right, so then I can go ahead and solve this. 1 minus 3 is a minus 4. A negative times a negative is a positive, so this is actually 6. And it gives me negative 2/3. So that's my slope. All right, let's go back to here. So I found m. Now I need to find b. All right, so next thing I'm going to do, number 2. There we go. Point slope. This is going to actually finish up the answer that they're looking for. Point slope form. All right, that is y minus y1 equals mx minus x1. All right, we just found m. We know it's this 2/3 here, so I can go ahead and plug that in, and then all I'm really looking for is the y-intercept. So let's go ahead and try that. So I'll move down here. Y minus y1. All right, so I'm just gonna plug one of those in there. So y1 can be, there it goes. Let's use this 3, -3, the first one. All right, so there we go. Y1 is 3, is equal to m. M is 2/3, so minus 2/3. X minus x1. X1 was -3. There we go. Now I'm going to go ahead and, there we go. I'm going to solve this part first just so it makes my equation cleaner. So I'm just going to rewrite everything. So y minus 3 equals minus 2/3 times x is 2/3 x. So that part's finished. No real heartache there. And then right here I have a negative times a negative, which gives me a positive. And I'm going to multiply that times this 2/3. So let's just pull it off to the side so you can see it. So negative 2/3, which is this. Remember, this is being multiplied into the entire equation. All right. But a negative times a negative is a positive. So negative 2/3 times, and I'm just going to go 3/1 because that's really what it is. So 2 times 3, 6. 3 times 1 is 3. Remember, this is still negative, so 3 divided into 6 2 times, so that gives me a -2. All right, and that's pretty much all I need. So let's put it back. -2 minus 2. All right. So now I got this side solved. Now all I have to do is just finish the equation up. The only thing I really need to do is just get this y by itself because that's what we're looking for. Once I do that, it's going to automatically put it into this slope-intercept form. Y is equal to mx plus b. We already found the m, that was a 2/3, the negative 2/3. We just found the b, which was the -2. So let's finish it up. Well, actually, we didn't find the b yet. We have to finish the other side. All right, so over here, I've got 3 on this side. I got to get y by itself. So I add a 3, I add a 3, and I'm left with my answer. Y is equal to negative 2/3 x plus 1. And that's how we write an equation in slope-intercept form. Now, if we could have, let's go back up here. If we could have seen that this was a positive one, my graph was not good enough. But if I could have just seen, hey, that's 1, I would only have to do this first equation because that would have given me my slope, and then I could have just read the graph to get the y-intercept, and then I could have just plugged it back in. But if we follow those 2 examples, we should be good. So do your slope formula first, followed by the point slope formula. All right, and once you reduce everything down, it'll put it automatically into our equation in slope-intercept form. All right, so follow those and you should be good. There it goes, focuses. All right, you're gonna have other questions. Stay still. All right, let me write some stuff down. There we go. You'll have some other questions where it just wants the slope. So we've already done the formula. I'll just walk you through one more. If I'm given -2, -1, and then 4, 3, all right, and it says find the slope. Well, all we need to do is just put in the slope formula. All right, remember, slope formula, slope y2 minus y1 x2, and that's all over x2, x1. All right. So once again, I'm going to come over here, just label my stuff. So this is x1, this is y1, x2, y2. That way I don't get confused. And then I'm just going to plug it into the formula. All right. So y2 is 3 minus y1. So minus y1. And that's over x2, which is 4 minus x1. So that's a 2. And then I just solve. Negative times a negative is a positive. Negative times a negative is a positive. So really I'm just adding together items. So that gives me 4, because 3 plus 1 is 4. And then over here, 4 plus 2 is 6. Remember, that's a negative, but that negative turned it into a positive. So it really turned into 3 plus 1. Negative times a negative, 4 plus 2. All right, so that's how I got that. But I can reduce this down, so make sure we do that. And I'm left with 2/3. And that's the slope of the line. So if you're finding slope, just make sure you follow this equation. Now, let's say we have a graph and we want just to identify an equation. All right, so let's say I have -2, 6 as a point, and I have 4, -3 as a point. So let's just graph that. So do the first one, -2 and 6. 1, 2, 3, 4, 5, 6. So there's that point. 4 and 3. 1, 2, 3, 4, and -3. 1, 2, 3. All right. All right. Now, if you get something like this and you can identify the y-axis, then we're good to go, or the y-intercept. The only thing we really need to do is just find a slope. So if they're asking, like, what is the equation? What kind of equation would you see? What they're asking for, let's go back to our first problem. If they show you this, and they show you a graph, or let's say they show you a bunch of different equations, and they show you a graph, they want you to be able to identify there we go. Oh, nope, that didn't work. They want you to be able to identify what this equation represents on the graph. All right, so that's what we're looking at. All right, so first things first, over here, let's say it actually hit the 3 mark. All right, so automatically I already know what my y-intercept is. All right, so remember, we're looking for y is equal to mx plus b. All right, if I can read the graph correctly and I say that's 1, 2, 3 up, I already know what b is. Done. So all I really need is the m. All right, and in order to get the m, we just need the slope. So let's go back and do that again. y2 minus y1 all over x2 minus x1, slope. Remember, slope is your m. That's what we're looking for. All right, slope equals m. So we just plug in the numbers. x1, y1, x2, y2. All right, let's go for it. So y2 minus 3 minus y1, which is 6. x2 is 4 minus x2, which is a -2. All right. Sorry about that. There we go. Now you can see it. All right, so now I got 6 and 3, which is going to give me 9. It's negative. All right, and then over here, negative times a negative is a positive. So we got 4, 5, 6. All right, and then I reduce down. So I end up with a -3/2. That is my m. That's right there. So if I had a choice of answers down below, the correct choice would be y is equal to minus 3 over 2, because that's my m, x, plus, and then over here I already said it was 3 because I read the graph. Now if I couldn't read the graph correctly, I would have done all those other equations like we did before, but I would just plug the 3 in and that would be it. Y-intercept, slope. To get the slope, you do the slope formula. Piece of cake. There, that way it focuses again. All right, reflections, x squared. Let's start with that, x squared, all right? If you have an equation and it's asking for reflections, if you have an x squared minus a number, remember, let's say a minus 15 or 14 or 0.2 or whatever. Just remember the negative moves your graph to the right. All right, so if that's your graph, and that's probably not correct, but I just threw it in there. If that's your graph and you have negative 15, your graph is going to move that direction. All right. If you have an x squared plus a number, your graph is going to move to the left. If you have a negative x squared, your graph is going to get flipped. Flips on axis. All right. If you have a fraction squared, then you end up with like mirrored graphs. So just be aware of that. Negative, you move to the right. Positive, you move to the left. If it's a negative x squared, it flips. And if you have a fraction, it'll go the opposite directions. All right. I think you guys already know that kind of stuff though. Let's look at absolute values. All right. So let's say you had f of x something. There it goes. All right, remember this graph basically looks like this. I think that's 90 degrees or whatever, but it's basically just a real sharp corner. All right. Now, absolute value, whatever's inside this, that's going to determine where this goes, right or left. Anything outside of this is going to determine where it's going to go, up or down. All right. Example, x minus 9. All right. In this case, the negative 9 is going to move your graph over. 1, 2, 3, 4, 5, 9. Bam. There you go. If you had an x plus 4, the only thing in here is the x. So that's this equation, all right? This 4 is outside of the absolute values. So instead of it moving right or left, it's actually going to move it up or down. All right, so in this case, we're going positive 4 upwards. So your graph would look 1, 2, 3, 4. It would start up higher. If you had an x to negative, a negative x in absolute value, it should be exactly the same as this one, because remember, absolute value is just the distance from 0. It doesn't really matter if it's positive or negative in here. It's just the distance from 0. So negative x inside absolute value is exactly the same as normal x. Just the same. There we go. All right. And lastly, if you have x over a number, let's say 4, all right, this as a fraction, what it does is it compresses this down. All right, so in this case, this is normal. That's your normal absolute value of x. If you add this number in, like a fraction, it squishes it. Makes it further down. That's kind of ugly, but I think you get it. If I added a larger number, let's say I made it 8, it would push it down even further. If I added a 2, it would bring it up a little bit higher. But you can kind of see what I'm looking at, what I'm getting at. So, inside the absolute values, this number, right or left, all right? This absolute value, if it's outside, it's up or down. That's it.